Welcome to a training video on TSI Certifier Flow Analyzers. In this video, I'll go over the Certifier's triggering functionality and provide some tips for troubleshooting challenging test setups. Certifier Flow Analyzers are often used to test ventilators and other respiratory devices that output flow and pressures in the form of breaths. Many test parameters are calculated on a per breath basis from flow rate measurements such as tidal volumes and minute volume, or from breath-based pressure measurements like mean airway pressure, peak inspiratory pressure, and positive end expiratory pressure. In order to calculate these breath-based measurements, the flow analyzer must be able to distinguish each individual breath coming from the ventilator, and its triggers that are used to define the start and end of each breath. TSI certifiers can trigger based off the flow rate, pressure, or a TTL voltage signal. On the certifier touchscreen display, the footer bar shows the current settings for breath triggers. Press on any part of this area to access the trigger menu or press the gear icon. Certifiers are capable of automatic breath detection based off the flow rate, and auto flow triggers will work for most test setups with bidirectional flows. It's recommended to start by using the flow auto triggers, and this option is set as the default trigger type for certifiers. If flow auto triggers are not providing consistent results, then you can use manual flow triggers. Unselect the Auto Trigger checkbox and specify your own flow rate trigger values. A positive slope through the start value is used for the start of the inspiratory phase of the breath, and a negative slope through the end value is used for the end of the inspiratory breath. Pressure triggers are intended to be used for testing high-frequency ventilators or for situations where triggering from the flow rate is not providing the expected results. Select the pressure trigger type option and specify your trigger values. Again, a positive slope through the start value is used for the start of the inspiratory phase of the breath, and a negative slope through the end value is used for the end of the inspiratory breath. Breaths can also be triggered with a TTL voltage signal that connects from the ventilator directly to the certifier. Users can select a high or low trigger voltage point. The TTL trigger method only works with specific ventilator models that output a TTL signal representing the beginning and end of breaths. If there is more than one flow module connected, the certifier will default to using the high flow option as the primary for triggers. For the Certifier Plus model, there will be an asterisk displayed next to the flow module that is controlling triggers for the instrument. A unique feature of TSI certifiers is the ability to visually observe the triggers in real time from the graph screen. Trigger timing is shown on the graph with a green vertical line indicating the start of the inspiratory phase of the breath, and a red vertical line indicating the end of the inspiratory breath phase. Measurements taken between the green and red indicator are used to calculate inspiratory parameters, and measurements taken between the red indicator and the next green indicator are used to calculate expiratory parameters. If you want to turn the trigger indicators off, you can disable the trigger timing feature in the graph settings screen. Trigger indicators can be displayed for all trigger types, and these indicators can be useful for verifying the performance of your trigger settings. If you're not getting the expected readings from your certifier, then plot flow rate or pressure on the graph to match the trigger type that's selected, and observe the indicators for several breaths. It may be helpful to add your measurements of interest below the graph so that you can view them at the same time as the trigger indicators. You can use the frequency measurement as a reference for determining the effectiveness of the current trigger settings. If the frequency readings are incorrect or inconsistent, then this is a sign that the triggers are not picking up the breaths properly, and it's likely that all the other calculator breath measurements will also be off. In the Averaging tab, the setting for number of breaths determines how many breaths the certifier will use for each calculated breath reading. When establishing trigger settings, it may be helpful to set the number of breaths to 1 so that you are seeing readings for each individual breath instead of an average reading taken over multiple breaths. If the flow auto triggers are incorrect or inconsistent, then it's recommended that you switch to using manual flow triggers. To determine your manual flow trigger values, plot flow rate on the graph and observe several breath waveforms. For robust triggering, be sure to set a start trigger value that is greater than the end value. As a helpful tip, try setting a begin trigger value above any flow or pressure signal noise that may be present in the waveform, and set an end trigger value below any signal noise. Another troubleshooting step is to confirm the physical test setup of your breathing circuit. For a bidirectional test setup, ensure that the Y fitting is placed before or upstream of the certifier. If using the 4090 Certifier Pro model, ensure that reverse flow is enabled on the high flow channel. For a unidirectional test setup, ensure that the Y fitting is placed after or downstream of the certifier so that it's located in between the certifier and the test lung. With this test setup, you can insert the certifier within the inspiratory limb of the ventilator to measure only the inspiratory flows, or you can insert the certifier within the expiratory limb to measure only the expiratory flows. If you're still having problems getting your certifier readings to match the output from the ventilator, contact TSI and our technical support team will assist you further. Once you obtain agreement between the certifier and the device under test, it's a good idea to save your current settings as a configuration. Configurations can be used to save your test setups for different equipment models, which can then be recalled the next time you need to test that particular device. Using configurations helps to minimize your test setup times and promotes consistent testing over time. You should now be ready to perform your testing. That's it for today. Follow me for more tips.